Let's continue with the gas laws. We mentioned in the previous video that for Boyle's law, P1, P2 equals V1, V2. Now let's see the simulation of gas particles. The particles in a gas are always moving and colliding with each other and the walls of the container. These forces can be measured as pressure, which is force per unit area. In a sealed system, when one condition is changed, it has an effect on the other conditions. So let's say we change the volume V equals 1 meter cubed, pressure equals 101 kilopascal, and temperature equals to 293 Kelvin. This example shows the volume decreasing while the temperature remains the same. As the volume is reduced, the particles will collide with each other and the walls of the container more often. The force will be higher and the pressure will rise. So as you can see, as the volume decreases, pressure increases, and the particles are now closer to each other and are colliding with the walls of the container. So P1 equals 101 kilopascal. 1 kilopascal is usually equals to 10 to the power 3 pascals. V1 equals to 1 meter cubed. So P1 V1 equals 101 times 10 to the power 3 Pascal times 1 meter cubed equals to 101 times 10 to the power 3 Newton meter. We obtained this unit since Pascal equals to Newton over meter squared times meter cubed, so meter cubed cancel each other, and we're left with Newton per meter. Now P2 equals to 202 kilopascal, V2 equals to 0.5 meter cubed. So P2 times V2 equals to 202 times 10 to the power 3 Pascal times 0.5 meter cubed equals to 101 times 10 to the power 3 Newton meter. So this justifies Boyle's law, which indicates that P1 V1 equals to P2 V2. When the volume halves, the pressure doubles. So here the volume is 0.25 meter cubed and the pressure is 404 kilopascal. Gases can be compressed because the particles are very spread out. When a gas is squashed into a smaller container, it presses on the walls of the container with a greater pressure. If gas is kept at the same temperature, the average speed of the particles stays the same. Remember, temperature is an indication of the kinetic energy. So if the same number of particles is squeezed into smaller volume, they will hit the container walls more often. Each particle exerts a tiny force on the wall with which it collides. More collisions per second means greater average force on the wall and therefore a greater pressure.